In Chapter 4, we'll take our first in-depth look at chemical reactions and aqueous solutions, or those reactions that take place in water. There are 7 sections in Chapter 4. We'll cover Section 4.3 first, grab one section from Chapter 5, then come back to cover Sections 4.1, 4.4, 4.5, and 4.6. Note that we'll be skipping Sections 4.2 and 4.7. Our first task involved describing and writing equations for ionic compounds dissolving in water. We'll use that skill to compare the behavior of ionic and molecular compounds in solution. There are a lot of learning outcomes in this section, so pause here to take notes if needed. Let's begin. When a compound does not dissolve in water, we call it insoluble, and note this with an S in parentheses behind the compound. A solid that readily dissolves in water is soluble, and we add the abbreviation for aqueous, AQ, in parentheses. Note that the AQ designation only applies to a compound dissolved in water. There are many other solvents out there, but we'll save those for Gen Chem 2. Many reactions happen in aqueous solution that would not happen if the same reactants were mixed as solids. Dissolved compounds are more mobile than solid compounds, which makes them more likely to bump into each other to form a product. Ionic compounds dissociate to form individual ions in solution, which are then surrounded by water molecules. On the left is a crystalline solid structure that could represent sodium chloride solid. As the solid interacts with water molecules, the ions split off, becoming hydrated or surrounded by water molecules in the process. When you see the AQ designation, keep this in mind. Ions will be surrounded by water molecules in solution. The mobile, hydrated ions in an aqueous solution of an ionic compound can conduct electricity. For this reason, we call them electrolytes and rank them according to how many mobile ions they produce in solution. Soluble ionic compounds, which dissociate 100% into ions in water, are classified as strong electrolytes. When a voltage is applied to a solution containing the ions of a soluble ionic compound, as shown in the middle image, the ions will migrate to the electrode of the opposite charge. If the electrodes are applied to the solid compound, the crystalline lattice does not allow for ion movement. Most molecular compounds dissolve in water to form non-electrolytes, since they do not fall apart into ions, but rather become hydrated molecules, such as solid ethanol dissolving into water. Acids are a unique class of molecular compounds that ionize in water to produce protons, H+, and anions that will conduct electricity. There are 7 strong acids that dissociate 100% into ions, resulting in their classification as strong electrolytes. Be sure to memorize this list. You'll need to know these throughout the remainder of your Gen Chem career. All other compounds that begin with a hydrogen in their formula are weak acids. Weak acids only partially ionize in water, resulting in their classification as weak electrolytes. This means you'll find the acid present in solution mostly as the intact molecule, with only a portion of the acid dissociated into anions and protons. Bases are compounds, when added to water, that produce hydroxide ions in solution, according to the Arrhenius definition. Like acids, bases can be strong or weak electrolytes. Strong bases will be those group 1 and group 2 metal hydroxide compounds that are water soluble. Weak bases will be molecular compounds that contain a nitrogen, such as ammonia, NH3. This table nicely summarizes the information just covered. We'll spend most of our time on strong electrolytes, the soluble ionic salts, strong bases, and strong acids, and the non-electrolytes, which are mainly hydrocarbon compounds that look like sugar, C6H12O6. A deeper conversation of weak electrolytes will be held until Gen Chem 2. If you'd like to try this for yourself, the textbook offers a conductivity interactive where you can add strong electrolytes, weak electrolytes, and non-electrolytes to water to see how it affects the flow of electricity. This is an excellent way to get hands-on experience and solidify your knowledge of the concepts presented in the last table. For now, let's practice. Can you classify the following compounds as strong electrolytes, weak electrolytes, or non-electrolytes? Refer back to the summary table if needed. As always, I'll leave you with the parting thoughts of the authors. Be sure to let the video play all the way through so that your score transfers back to Canvas.